Okay, let's get started with lesson 5.3, which is a critical look at proportional relationships. So I'm hoping your brain is buzzing right now with thinking about what did I learn about proportions in 7th grade, because that is where you learned the most of your proportional relationship understanding. Okay, so we're going to start with this problem here about Paul. It tells us Paul walks 2 miles in 25 minutes. And they ask us to find how many miles can Paul walk in 137.5 minutes. Okay, so let's start off by thinking about this a little bit. So if Paul is walking for 25 minutes, I know that he goes 2 miles in distance. So my question for you is, what if he walks for a total of 50 minutes? I want you to jot down right here, how many miles do you think he's able to walk if he walks for a total of 50 minutes? So I'm hoping you wrote down, well, 25 minutes, if I double that, that's 50 minutes, right? So he should be able to walk double that distance, and double that distance would be 4. Okay? Now let's say he walks for a total of 75 minutes. Write down what you think his mileage would be after walking for 75 minutes. Okay, I'm seeing now that, well, 75 is just 25 3 times, so 2 3 times would be 6. And again, let's look, how far would he walk if he walked for a total of 100 minutes? Hoping you put 8 there. Okay, what if he walked 125 minutes? How many miles do you think he would walk then? And I'm hoping you put 10 here. Okay, so this is an interesting relationship here. Every 25 minutes that he walks, he goes another 2 miles in distance. So this is actually called a proportional relationship, which you could probably have thought of because of the title, right? So what we have here is two things. We have time and distance. So we have his time and his distance. Okay? If I know his time and his distance, and I know it's a proportional relationship, okay, then I know for every 25 minutes, he's going to walk 2 miles, right? This is constant, okay? If I wanted to know how far he's able to walk in 137.5 minutes, I can figure that out, right? First thing I'm going to do is I'm going to say, let y be distance, okay? And then I'm going to set up a proportion. A proportion is when you have two fractions that are of equal value, even though they look different, okay? So I know one of my fractions is 25 over 2. So here I'm doing time over distance, okay? Something else I know is that I want to know how far he's going to walk in 137.5 minutes. So here's also time, 137.5. And I already said let y be the distance. So y is what I don't know. I don't know how far he's going to go. Okay, so I have these two fractions set equal to each other. I set up my proportion, and one of my items is a variable, which means we have to solve for that variable. We should know how to solve a proportion. We've done this a couple times in class too. We cross multiply, and then we divide or simplify. Okay, so when I cross multiply, I'm going to write this on the other side of the table. When I cross multiply, I get 25y equals 137.5 times 2. 137.5 times 2. So 137.5 times 2. 0, 1, 14, 15, 6, gives us 265. So I get 265. Okay. Now, I'm still trying to get y. I'm trying to figure out what y is. So the next thing I would do is I would divide by my 25. Just like that. And I get y equals I do this, I'm going to get y equals, and then I need to do top in, bottom out. So 265 divided by 25, that's 1, 25, I'm left with 15, doesn't go in, so 0. 150, that's 1, 2, 3, 4, 5, 6, so we're left with 10.6. So what this means is that when Paul walks for 137.5 minutes, he's able to walk for 10.6 miles. So 0.6 miles more than he did in 125 minutes. Okay? So our next example is actually more of a discussion. That's why I kind of highlighted it right there. So it's a great discussion, but it's not really important for you to get the gist of this lesson. So I'd rather go down to example number 2. And if you're ahead on your lessons, then you can come back and watch what's happening in this situation right here. Otherwise, I don't want to waste our time on that. Okay, so we have another example here, and here we're talking about Wesley, and he walks at a constant speed from his house to school 1.5 miles away. And it took him 25 minutes to get to school. It says, what fraction represents his constant speed? Okay, so let's look at that first. What fraction represents his constant speed? Okay, so I'm hoping, I know that you've learned this, I'm hoping you remember that speed is equal to distance over time. So I'm going to read this problem again, and I'm trying to identify what is the distance that he's going and in what time was he able to do it. So he walks 1.5 miles away. So here's his distance. And it took him 25 minutes. So here's his time. Okay, so if I wanted to write his constant speed, c, I would take his distance, 1.5, and I would divide it by the time, 25. Okay, so this number right here is what we call his constant speed. Okay, we're going to use this constant speed to figure some stuff out. So it says you want to know, we're looking here at B part now, you want to know how many miles he has walked after 15 minutes. Okay, let y represent the distance he traveled after 15 minutes of walking. Okay, so I'm going to remind myself what speed is. It is distance over time. And I know what our constant speed is because they told us it's 1.5 over 25. And I know if he's going at a constant speed, then every other constant speed that he goes at should be the same, even if it looks different. Okay? So they tell me to let y represent the distance. Let y represent the distance. I see my distance is on the top, so I'm going to write y on top, just like that. And it says that he has traveled in 15 minutes. Time is on the bottom, so I'm going to put my 15 on the bottom. Okay? And then they say write a fraction that represents the constant speed c in terms of y. So that's what I've done here. This is also my constant speed, even though it looks different than my original constant speed. Now, the next part asks us to write fractions, not tractions, from parts A and part B as a proportion and solve to find out how many miles Wesley walks after 15 minutes. So looking here, I'm going to rewrite my fractions that I already had, 1.5 over 25 and y over 15. And they're asking me to solve this proportion. And we should remember, to solve this proportion, we need to cross multiply. So, 15 times 15, 5, 2, 5, 6, 7, 0, 15, 5, 2, 1, 225, but one of them is a fraction, okay? So this is 22.5 equals 25y. Going to divide both sides by 25. Cancel this out. We're left with y. And we're going to do this division here. So 22.5 divided by 25 lets us know that y equals 0.9. Okay, so this means that after walking for 15 minutes, he's gone 0.9 miles. So that means in 15 minutes, he almost went a whole mile. Okay, so now we're going to do this last part of the problem, which is actually kind of like the biggest part of the problem. And it's really algebra focused, so I want you to keep this in mind. Okay, let y be the distance in miles. Okay, we did that once already. That's what we have up here. Okay, that Wesley traveled after X minutes. Okay, think about what they're doing here. So we knew that y was miles, but now they're telling us X is minutes. So now we have a y and we have an X, and we're going to put them both into this equation and see what happens. Okay, so we already have our constant. We know our constant is our distance over time. Okay, and they told us our original one was 1.5 over 25. Right, that comes straight from the first part of the problem. Okay, but now they're telling me that y is my distance and x is my time. That means I don't know the distance and I don't know the time. Okay, this is what we actually call a linear equation in disguise. So a lot of you were writing linear like linear. No, it's linear. Linear, like a line. Okay, linear. Okay, so this is a linear equation in disguise, and I'm going to show you how to take the disguise off. Okay, so to take the disguise off, you're going to need to cross multiply. Okay, that's going to give me 25y, right? 25 times y equals 1.5x. Okay, now I want to solve this for y, which means I want to get y by itself. So think about how I could get y by itself. Right now, y is attached to the 25. It's attached by multiplication. What undoes multiplication? Division. So that means I need to divide both sides by 25. Cancel, cancel. And we get y equals 1.5 divided by 25. 1.5 divided by 25. Okay, and I think it's actually fair for us to leave it like this. Okay, so now what's so great about this right here is that now, no matter what I want to figure out, I can plug it in to figure it out. So for example, let's say I wanted to know how far Wesley is going to walk in 50 minutes. Okay, let's remember what represents what. So in this problem, x represents minutes, right? So if x equals 50, right? This is a 50, it's a 5. Okay, if x equals 50, I can plug this into this equation and I can figure out how far he's going to walk. So I can say y equals 1.5 over 25 times 50. Okay, I can use my fabulous math skills and I can see, oh, 25 goes into 50 2 times. Okay, then I can use even more fabulous math skills and I can say, oh, well, that's 2 times 1.5 is 3. So I know that in 50 minutes, Wesley will walk 3 miles. Amazing. Okay, so let's take a look at our group work. For our group work, we have 3 problems. I would like you to do this first part, okay, and then check the video. Do the second part, then check the video. Do the third part, then check the video. Do the last part, and then check the video. Okay? The same for number 2. Number 2 is a little bit simpler. Okay, it kind of gives you an example there. Do the entire table and then check the video. Number 3, do the entire thing, and then check the video. So only number 1, do in pieces. Got it? Got it.